So as we move on with our fractional exponents, we're now going to do some computation in which we are going to multiply these. But notice that when we are multiplying, in this case, we're going to be adding exponents. So in order to add fractions, they must have the same denominator. So a strategy. You put the 10 there. Your common denominator is going to be a 9. And this will make into a denominator of 9 by multiplying it by 3. This one by 3. 3 over 3 is 1. We are allowed to multiply anything by 1. And this becomes 6 plus 1. So this will become 10 to the 7/9. So again, we're multiplying, but in the case of exponents, in this case, we are going to add fractions. We have to have common denominators. And if you wanted to put this in radical form, it would be the 9th root of 10 to the 7th. All right, here we're going to do something a little different because now we're raising powers to a power. So in this case, when it's outside of the parenthesis, we have to multiply. So this is going to be 81 to the 1/4 times 2, which gives you, this will cancel a little bit if you want, or 2 over 4, which is 1/2. And then x, again, this is 6 over 4. So 2 times 3, or we could have canceled, that could have become 3 over 2. Let's do it that way. And now we know the square, the 1/2 power of 81 is the square root of 81, which is 9. And this is going to be the square root of x to the 3rd power. So that's what this becomes. Now again, if they didn't want it in radical form, you could have left it this way. These two are equivalent. Here's fractional exponent, there's radical form. But we do want to take the square root of 81 to get the 9. All right, here we have negative exponents, but we're just adding anyway. So x, my common denominator is 3. 6 minus 7 will be x to the 1/3, negative 1/3, which then becomes 1 over x to the 1/3, or 1 over the cube root of x. Again, you can always go back and replay the tape, but let's review this. The denominators are the same. We're going to, in the case, subtract. Set it up like so. This becomes a negative 1 over 3, which as a positive exponent becomes this, and then in radical form becomes that. Number 14 gets a little challenging. Want to be sure I copied it down right? Yes. Again, all these are from additional exercises 10.2. So here we're multiplying. This is going to become x to the 1/2, y to the 1/4. And then we want to, now that we've gotten it out of the parentheses, we're going to add like terms and common denominators. So for our x, these are our 2 x's. In fact, I'll write it here. X to the 3/2, y to the negative 4/8. So we'll pull out our x terms first. This will be x. Common denominator is 2 already. So it's just going to be 1 plus 3. 1 plus 3. So this is 4 over 2. So this is going to become x to the second power. 4 divided by 2 is 2. Now in the case of our y's, we have y. We need a denominator of 8, and there's our 4. Now to get this to be 8, we got to multiply it by 2 over 2. So this becomes that. So we now get 2 minus 4 is a negative 2. So this is going to be y to the negative 2/4, which is a negative 2/8, which is a negative 1/4. So this, I think I ran out of room, will be x squared over y to the negative 1/4, or you could write this as the 4th root. Well, actually, when I move it down, it becomes positive. The 4th root of y. So let me write that again. As this negative exponent goes to its denominator down here, which is what I put it, it becomes positive. And that would be x squared divided by the 4th root of x. Again, not too hard. The numbers weren't big, the fractions were easy. You just needed to know how to deal with them. Now, once we have fractional exponents, we can kind of swing this way or that way between the two. We were using it a little bit before, so let's see what we have here. So if we take away the radical sign and convert it to its fractional exponent form, this becomes x to the 3 over 3, y to the 6 over 3. And you recall I had mentioned this technique earlier of using the index number to do this. This will then just become x y squared. Now in this case, we're going to take away the radical sign and bring our index number over here. And this then becomes y minus 7 to the 1/2 power. If you want to put it back in radical form, it's the square root of this. And for this one will be a to the 3 over 12, b to the 9 over 12. And then this becomes a to the 1/4, b to the 3/4, or this could then become the 4th root of a b to the 3rd. So you've simplified this going through fractional exponents, and that would be an answer. Now in number 18, as we look at that, we see, wait a minute, they're not the same index number. So how can we multiply that? Well, the answer would be through fractional exponents. This becomes a to the 1/2, changing it from its radical form to its fractional exponent form. And this becomes let's see here, 3b to the 1/4. So as we continue here, we're looking to write these as a single radical expression instead of two like this. So we change that to its fractional exponent form and this. Now, since we want to put it under a common radical sign, this 1/2 had to be changed to 2/4. So now each of these have the denominator of 4. I could put that in my index number spot, and this become a to the second times the quantity 3b to the first. In number 19, they're asking us to FOIL here. So let's follow this slowly here. 5 times 3, my first, gives me a 15. Now when I multiply this times this, I have to add my exponents. And 1/4 plus 1/4 gives you 2/4. Then I did my outers. 5x to the 1/4 times 2 gave me 10 x to the 1/4. Those were my outers. When I did my inners, I got a negative 12x to the 1/4. And then when I did my last, I got a negative 8. That was the easy one. Okay. Now these are like terms, so I want to add them, in this case subtract, and I get a negative 2x to the 1/4. And when I simplified the 1/2, or the 2/4, I simplified it to 1/2. And then this is what I have. Now if you wanted to write this in radical form, it would be 15, the square root of x, minus 2, the 4th root of x, minus 8. These would be equivalent, but one's in radical form, the other's in fractional exponent form. All right, going to this last one, I put some of the work up to shorten the time. But it's the 6th root of this and the 3rd root of this. I converted this then to its fractional exponent form, as I did with this one. Now, since we're going to be subtracting fractions here, I have to have a common denominator. So my 2/3 I converted to 4/6. I then brought this 4/6 up to the top, subtracted it from that, and I now get x to the 1/6, which is the 6th root of x. So we started with something like this, went through the conversion to fractional exponents. That's where they're useful, by the way. And in logarithms, you'll be doing some of this a little later on as well. Okay, that wraps up this topic. We'll go on to 10.3.